This is chapter 6, problem number 32. The lucky number for this problem is 4, number 4. That's the lucky number. All right, a person named Jane is running at a top speed of 5 meters per second and grab on a string or a rope. Okay, so what is the highest that she will go? Okay, that she will swing up. Okay, does the length of the rope affect the answer? Okay, so what happened is this person is running very fast, going in this way, in this direction. Okay, so there is a rope over here. Okay, so when she comes over here, she grabs the rope and hang on it, and the next moment is going to swing up over here. Okay, so the question is, what would be the height? How tall should Jane swing up? Okay, over here I call this 0 height. So when Jane is running, do we have kinetic energy? Yes. What is that? Kinetic energy is equal to half mv squared. As long as an object is moving, it has kinetic energy. Okay, so kinetic energy, okay, what is the potential energy here where h is equal to 0? So at this moment, potential energy due to gravity is equal to 0, okay, because it is equal to m times g times h is equal to mgh, because h is 0 over here in the ground. Once she grabbed the rope, she lifts her legs, her feet, and let it swing up. How high will it be? The highest point is when she stops. So over here, very fast, slow, stop. If nothing going on, if she doesn't jump off, okay, then she will behave like a pendulum. It will swing back. So the highest point is where she stopped over here. That would be the highest point. When she stopped over here, what will be the kinetic energy? Kinetic energy at this point will be equal to 0. Okay, so at the beginning, potential energy is 0, only has kinetic energy. Kinetic energy is half mv squared. Okay, over here, kinetic energy is equal to 0 because it's not moving. Okay, at the highest point, potential energy is equal to mgh. All right, so kinetic energy plus potential energy of the initial state should be equal to kinetic energy plus potential energy in the final state. So that is the concept of conservation of energy. That means the energy of the beginning should be equal to the energy at the end, the final state. Okay, so that means when you add these two up, you have half mv squared. That should be equal to mgh. Okay, over here, I can cancel out my m. So h is equal to half times v squared and divided by g. Okay, so over here, I have h equal to half v squared. So it's v squared divided by g. So that is equal to, v is equal to 5. So 5 squared, that is 25 divided by 2 divided by 9.8. Okay, so the height is 1.27 meter. That means when she runs at 5 meters per second, grab a rope and allow it to freely swing up, it can go to the highest point of 1.27 meters. Okay, the lucky number for this problem is 4.